So, welcome everybody. This is the Docker and Kubernetes workshop on defense. I like to talk about offensive side mostly, but this time I will talk about defense. It's also very important, and I believe that there is not so much information on Docker and Kubernetes defense. So it's going to be pretty interesting. My idea is to do a walkthrough the security features of Docker and also Kubernetes. Is this one to move forward? Well, my name is Sheila, or Sheila in English. I work as head of research at Dreamlab Technologies. This is a Swiss company, but I'm from Argentina. I'm talking to you from Argentina, my country. Well, as I said, I'm a phantom security specialist, but I mean, I like to break everything, but sometimes I have to do defense as well. So I'm also a developer in assembly, C, C++, Go, Python, and related to what we are talking about today, and also a Docker captain. This means that an DCA certificate. As a speaker at training, well, I was giving trainings at HITB, Black Hat, DEFCON, Echo Party, and other security conferences all around the world. So I will stop sharing my video for now. So because my South American internet connection is not so good, so I'd rather to share the screen and stop the webcam for now. Good. So this is our agenda for today. We'll start talking about securing the Docker daemon and its core components, the Docker socket, the API, other core components of Docker. And then we will jump into securing Docker containers, Docker images, and finally we'll talk about securing Kubernetes orchestrated environments. The first part is going to be a little bit more theoretical, and then we will jump into several practices and live demos, especially in the Kubernetes section. Okay, so let's start. First, as I said, we will talk about the Docker daemon and core components. Good. In a normal Docker installation, the Docker daemon runs as root. But we can address this by using the rootless kit. It allows us to run the Docker daemon within the user namespace. There are a couple of prerequisites that we must meet to install the rootless kit that vary depending on the Linux distribution of the host machine. Here in this link, you can find them. But for example, if you're using Ubuntu or Debian as host in your host machine, nothing else is required. So once you have your host machine ready, you can follow just 3 very basic steps to install the rootless kit. The first one is just download and run it. We have to download it from this URL since this kit is not part of the normal installation. And second, it's necessary to export these 3 environment variables since the rootless kit uses different paths than the normal installation. It uses paths where a non-privileged process can read and write, right? Finally, we can just run the rootless kit, the Docker daemon in rootless mode, by executing this command. And in the latest version of Docker, it's not necessary to pass this flag. The experimental flag is no longer necessary. And also the storage driver specification is not necessary for some specific distributions. But once done this, we can check that our Docker installation is actually running as rootless by running the docker info command. And we will find that under the security options, we have rootless here. So that means that we are actually running Docker in rootless mode. But this basically means that the Docker daemon doesn't run as root anymore, and following the principle of least privilege, this is a good practice, right? But unfortunately, this is not always possible. The rootless mode has several limitations. Still, there are some features that the rootless kit still doesn't support. For example, AppArmor, the overlay network that emulates this one is pretty critical, because in a production environment, if you're using Docker, you will probably implement Swarm. This overlay network driver is very important. So there is still a couple of things that doesn't work, and some of the features that doesn't work in rootless mode are related to security as well. For example, AppArmor is one of them, and also cgroups or control groups are used for security as well. But still, it's possible for us to use the rootless kit. We should go for it. I recommend to check the official Docker documentation on rootless, because it's very good. It's explaining how to install it. We already saw that it's just a couple of steps, very, very easy. But then you can also find the limitations and some ways to address some of them in order to run the rootless kit. And I would like to do a special mention for other daemons or container runtimes. Perhaps you already hear about this, but for example, Kubernetes will no longer support Docker. That is not as critical as it sounds. I mean, you can still use Docker images on Kubernetes because Docker uses containerd already. Containerd is another container runtime. It's just that Docker is a stack of technologies, and Kubernetes doesn't want to continue supporting all the stack of Docker technologies because Kubernetes just needs the container runtime. So if you are using a cloud provider with Kubernetes, cloud providers will migrate. One of the next version of Kubernetes will no longer support Docker, and they will migrate to containerd as container runtime. This doesn't really affect you so much. I mean, you can still use, here someone is sharing a link, don't panic, Kubernetes and Docker. Yes, you don't need to panic, actually. As I said, you can still use your Docker file, you can still run images from Docker Hub, and it looks like nothing really changed so much. But if you are running a cluster on-premise, you will need to do the migration. So it basically means that you will need to remove Docker and install containerd. As I said, that's all is not as catastrophic as it sounds. Good. So containerd, as it was investigating a little bit the last day, it also had as rootless kit. I saw people working actually on projects for rootless mode, also for Kubernetes. This one, Usernetes, is an alternative as well. I find it interesting to investigate these alternatives because if possible for our needs, it's good to use rootless mode, right? Good. What about the Docker daemon? Well, someone is checking the chat. Someone is sending regards. Okay, thank you so much. Okay, so the Docker daemon can listen for API requests via 3 different types of sockets: Unix, TCP, and FD. But by default, a Unix socket domain is created at /route/run/docker/doc/sock. This Unix socket can be used to communicate with the Docker daemon from within a container as well. This is the socket that we use, for example, when we run the command from the Docker client. The Docker client talks to this socket. But as I said, this socket can also be bimodal inside containers. As we search on GitHub, there are more than 260,000 projects that bimode the Docker sock inside containers. And this practice is a little bit dangerous because an attacker who compromises a container with the Docker sock bimoted can talk to this socket and take control of the whole cluster in most cases. Unfortunately, this practice is common because in some scenarios it's not possible to avoid it. For example, in the case of a CI/CD environment, it's pretty common because Jenkins, for example, we need to create containers, so we need to talk to the Docker sock in order to do that. But in the last time, there are some alternatives. There are some projects, also, for example, the rootless kit has now an image to run Docker within Docker in rootless mode, and it's interesting to take a look at those alternatives in case you need to, for some reason, talk to the Docker daemon to create containers or whatever. I would recommend to take a look at those alternatives, or in worst case, apply for a defense in depth, right? Good. We also have the TCP socket, as you said, and this can be enabled if remote access to the Docker daemon is needed. But you have to be aware that by default, enable this provides unencrypted and unauthenticated full access to the Docker daemon through this API that can be accessed via HTTP. So guess what? Yes, if you look at Json, there are thousands of Docker installations using this API to the internet. So unfortunately, an attacker may take control of most of these clusters with a few commands without even prompting for authentication, right? So we have to try to avoid this, or if you actually need to remote access to your cluster, we can use the built-in HTTPS encrypted socket for it. In order to implement it, it's necessary to create a CA and server keys for our cluster. We can do it with a few commands, for example, using OpenSSLs. And then we can run the Docker daemon with the TLS verify flag. And these flags that you can see here are used to pass the CI certificate, the server certificate, and the server key. In this way, you are running the Docker daemon in a secure mode, right? After doing this, the Docker daemon will only allow connection from authenticated clients using a certificate signed by the CI of our cluster. Here in the picture, for example, we can see that a connection attempt is refused. And on the server side, here, the daemon log says that there was an attempt to connect, but it was rejected because the client did not provide a valid certificate, right? So this is the right way. I mean, if you need to expose the Docker API, please don't do it as default, because as default, everybody is allowed to connect to your cluster and do whatever they want. So please use a certificate at least. And it's actually very easy, and run your Docker daemon with the right certificates. But of course, Now we can see here the picture that a remote connection is refused because we need to provide a certificate. So on the client side, we need to create certificates for the user. And those certificates need to be signed by the CI, right? And we have, as user, we have to provide the certificates in every API request. If you are used to use the Docker command line, the Docker client, for example, here we have a command that is Docker version, just a simple command. But the difference is that we are talking to a remote host, specifying it with the H flag, and we are passing the certificates. Yes, we are passing the CI certificate, the client certificate, and the client key. Of course, we can generate these certificates using OpenSSL and make sure that you are signing them with the CI of your cluster, right? We can avoid passing the certificates in each of the requests. We can just copy the certificates to the .docker folder in our home and then export this environment variable. So Docker will automatically establish a secure connection to this host using the corresponding certificates. So finally, here in this picture, we can see on the left side the Docker daemon running with certificates. Also, in this case, I made this example using the rootless kit, because the rootless kit can also listen for remote connection with using certificates. And the client machine, we are just querying the remote Docker cluster using our certificates, and the connection is successful, right? Good. Well, as I said, this part was kind of theoretical because I don't want to alter my Docker installation right now. I need it for the practices. But basically, the important thing is to run the Docker daemon as rootless if possible, and also make sure that your Docker API is not exposed to the internet without any protection, right? Good. If you have any questions, please feel free to drop them on the chat here in Zoom, and I will answer them. So for now, I will move forward securing Docker containers. Good. So first of all, it's key to understand the first and main isolation layer of Docker. Containers are not virtual machines, as many people say. Containers are processes on the host machine, right? Docker uses the Linux kernel namespaces to isolate those processes so that they cannot neither see nor affect other processes. That means other containers or processes on the host machine. These ones are the 6 kernel namespaces that Docker uses. The first two, UTS, the UTS namespace isolates the system identifiers. This means, for example, the host name. I will show you right now that the host name of the containers is different than the host name of the host machine. And also the PID namespace is very, very important because this one is the namespace that can isolate the processes of the container. And let me show you how this looks like. Here I have my console. So for example, let's run a container here just to take a look at some stuff. In this console, I will run a container and I will open one more. And this one is going to be here in my host machine. Right, so if I execute the hostname command in my host machine, I can see this one is my hostname. But if I run a container and run the same command, I can see that the hostname is different. And if I change the hostname here in the container or in my host machine, it doesn't affect the hostname of the other. For example, if I change the hostname in the container, it doesn't affect the hostname of the host machine. And this is thanks to the UTS kernel namespace, right? And also, as I said, Docker uses the PID namespace to isolate the processes. So, for example, if I run in my host machine the ps command, I can see a lot of processes. This is normal. In any computer, you will find a lot of processes. But if I run the same command inside the container, I only see two. And it has to do with this namespace, because this namespace provides the isolation, and the process of the container can only see the, its child's processes, right? And we will only see the processes running inside the container process. This is also a good trick to identify containers. If you are performing a black box analysis, or you compromise, I don't know, a web application, for example, and land it inside a container, but you are still not sure if you are actually inside a container or not, you can run this command and check the processes. Because if you are in a normal server, you will see, like, on the right side, a lot of processes. But if you are inside a container, you will see 2, 3, or 4 processes. So that's also a good trick to identify containers in a black box analysis. There are actually more tricks to identify that you are inside a container, but that's out of the scope of this workshop. I used to explain that in the offensive one, but it's about defensive, so let's move forward this. Oops. Okay, we also have other two namespaces, the IPC and net. The IPC isolates the IPC resources. I guess I don't have IPC resources in this computer, but for example, in the host machine, I run IPCS/A. If I have resources here, I will not see them in the container. I can run the same command in the container, and it's clear. But if you try to do this in Linux, for example, you will probably see in your host machine several IPC resources, and they will not be present on the container. This is isolated by the Linux kernel namespace IPC. And also, Docker uses the net namespace to isolate the network interface. So by default, a container cannot see the network interfaces connected to the host machine. If I run here and config net, I have several networks here. If I run this config here in the container, I should see two, the local one and the Docker network. This is the default network interface that is attached to every container. So as you can see, there is a difference here, and this is thanks to the net kernel namespace, right? But it is possible to share. If we want to, we can share the namespaces between the containers and the host machine. Of course, it's not recommended. I mean, if you share a namespace, you are breaking an isolation layer. So I don't recommend to do that. But for example, let's exit this. if I run design container before, but let's change this network host, this means that I will share the network namespace with the host machine. So now if I run this config, you can see that I have many others interfaces, right? So same way we can share the IPC resources, we can share the PID and the others namespaces. But as I said, this is not recommended because you are breaking isolation layers. But in case for any reason you need to do it, is actually possible. Good. Back to the presentation. Docker also supports the user namespace. By default, it's disabled, but this is a super interesting namespace, and I will talk about it later because we can make use of it for security reasons, and it's actually very interesting to use. And then the mount namespace, it's for isolate the file system mount points. So, okay, the use of these namespaces provides the first layer of isolations at containerized, right? It's very important to understand this. We are not talking about virtual machines or something like that. Containers are processes in the host machine, and Docker uses the kernel namespace to isolate them. Good. So let's talk about the kernel capabilities. This is very, very interesting as well. Docker drops most of the current capabilities for the containers process. This means that by default, the root within a container has less privileges than the root of the host machine. This sounds a little bit weird, but basically it's just that the root. I mean, we know that by default a container runs root. So this root user maps the root user on the host machine. As we checked here, the container process is running as root. But if we get the capabilities of the process, we can see that are not all the possible capabilities. Let's check this here in the practice. There are several ways you can get the capabilities of a process, but if you are inside the containers, you can install the libcat, for example. And then run the command cap ssh print. And here you can get the default capabilities of this process, right, for this container. But it changes if we, for example, run a privileged container. It exists a flag named privileges in Docker. Privileged. And this allows all the kernel capabilities for the container. This is actually very, very dangerous. Let's rerun it and let's again install libcat. And let's check now what have changed. And look at this. We now have all the kernel capabilities allowed for this container. And this is dangerous because we have allowed, if I can find it, this one, cap sysadmin, that allows to basically alter the host machine. So this is not an offensive workshop, but it's very, very easy to compromise the host machine if we have all these capabilities allowed. It's just 4 free commands in this container and I can get out of it. So please try to avoid using privileged container. Because if you are using a privileged container, basically you're breaking all the isolation layers of Docker. So I saw that many applications have this as a requirement, but at least you now are aware that this breaks the isolation layers. So if an attacker compromises a container with these capabilities, can get out of the container sandbox. Good. So if you're in Linux, there is another way to get the capabilities from outside the container. You can use the get pickups command to get the capabilities of the process that you are running inside the container, but from outside it, from your host machine. Good. You might wonder, can we choose the capabilities that will be enabled? And the answer is yes. Docker supports the addition and removal of kernel capabilities. It allows us to make a fine-grained access control system, which is very, very interesting. Let's see an example. I will show this also in a live demo because it's actually very interesting to see. Get out of this. So let's run again a container. Let me attach this one. It's an Apache. And you can use the cap -drop equal all to drop all the kernel capabilities. But if we do this, we need to be aware that probably some things are going to fail. Let's do a first try. Here basically I'm running an Apache and passing these flags to drop absolutely all the kernel capabilities for this process. And now, if we do a Docker containerized, we see that there is no container here. It means that it's basically an error. So now I have here Apache 1. And this one is the one I run just. And if we can check the logs, see, just to be aware why it's failed. Container logs, Apache 1. And here we can see that it wasn't able to bind the port. And it happens because if you need to bind a privileged port, it means from 0 to 1024, it will need a kernel capability to do it. Otherwise, the process will not have enough permissions to bind the address. So we can try again, but now let's add the kernel capability that the process actually needs. So we can do it with the cap add flag. And the capability that the process needs to be able to bind a privileged port is cap net client service. So basically now we are dropping all the capabilities, but then we are adding one. And we can add these flags so many times as we need to add the kernel capabilities that our application needs, in this case, the Apache web server. So now if we do a Docker containerized, we can see that our server is running and we can actually check it. Localhost, that it's working. So, but this is good. I mean, we can just drop the capabilities that are not necessary for our application and allow only the ones that the application really needs. And with this, we are reducing the power of the root user running the processes within the container, right? Good. So here I just have some screenshots of the same example. Well, if you want, you can check that the capabilities allow are actually the only one that you will see is the one that we have enabled. So you can, if you are in Linux, you can use this command to get the process ID of the HTTPD server and check the capabilities. Good. So let's jump into system code restrictions. So we already know that the kernel is shared between the host and the containers, right? So containers are processes on the host machine, and they share the kernel with the host. So it will be good not to allow containers to execute some system calls that might alter the host machine, right? Docker supports seccomp, and this is a kernel feature that determines whether or not to allow a process to execute a system call based on a seccomp profile applied to such process. Of course, there is a default profile that Docker uses, which I find it's very good. I mean, it blocks several system calls, but also allows several ones. I believe that this allows the necessary ones. I mean, you cannot block all the system calls because the container will basically won't work. You can use a custom one if you want to. If you want to specify a custom seccomp profile, you can use this security option flag and specify the path to your profile. Seccomp profile is a JSON file, and the container will run applying that seccomp feature. There is a couple of tools to generate seccomp profile. Let me say that it's not so easy. You need to track all the system calls that your application needs to properly work. As I said, there are a couple of projects that help us to do it. For example, this one, seccomp-gen. And seccomp-gen uses strays to get the system calls needed by an application and generate the seccomp profile. This is very useful, but still is not enough. I've been using it, and it helped a lot to collect several system calls that our application actually needs. But still, we need to do some manual work. And sometimes it's very tedious to find all the necessary system calls. But if you want to run your container in super paranoid way, it's possible. You just need to take your time to track all the system calls that your application needs and block all the rest. The idea is to allow only the necessary system calls for our application. But to say this is not so easy, but it's possible, right? If you want to, it's possible to do it. Okay, well, Docker also supports mandatory access control through AppArmor or CLinux. These features helps restrict, among other things, the ability of processes to access or perform certain operations on system objects. Again, there is a default profile that Docker uses, but we can create a custom one for our application. Bane is a tool to generate custom AppArmor profile for Docker containers. We can create one and load it on our system with this command, and then apply it to a container using the security option flag. In the official Docker documentation, I guess I have this somewhere here. In the AppArmor page, I'm sure it's on the chat if you want to check it. There is an example of an Nginx profile, AppArmor profile. And if we take a look at it, basically you can deny access to different resources, to different paths, different network resources, capabilities, and so on. So I find it very, very interesting. But again, you need to take care of not blocking resources that your application might need to use. But if you are in Linux and you want to try this feature, it's actually very easy. You can save the file, the profile that is published on the Docker or documentation that I should share in the chat, and save it as a JSON file. And then you can use the AppArmor parser to load it in your system. And then you can run an Nginx container applying the AppArmor profile. Here we can see in the screenshot that if I get a shell inside the container and try to create a file, so it's using a touch hello, for example, it says that I don't have permissions to do it. So basically, you can apply a very restrictive profile. And it helps for security, as if an attacker compromises the container and cannot write anything on the file system, is actually very useful. So I recommend to do it, but of course, same as the subcom profile, it takes time. You need to create the profile, the custom profile for your application. It takes time to track the system calls, to track the permission that your application actually needs to work. And it's something that is custom for every application, right? But as I said, there are a couple of tools that help us quite a lot. Pain, in this case, is pretty useful to create custom profile for AppArmor. Good. So, well, it's well known that the user within a container is root. We already saw that. And this root user maps the root user on the host machine. We already saw that it has less power because the root of this process has less capabilities than the root of the host machine, but it's still powerful. In principle, this is easy to address. We can use the user parameter to specify a different user other than roots. For example, I'll be back to my console. So if we run a Docker container, so by default, is via who I am. So by default, we are root, yeah, but we can use the user flag and specify a different user ID. So now we already see that we are not root basically for the the symbol that we have here. That is, we can check it, and it says that we are 2000 user ID. So basically, we are not root. And if we check on the host machine, So, for example, if I run the sleep command here, and then do a ps sleep on the host, and we can see that this is okay. I am in the host machine in my physical. As I'm using Mac host, I need to get inside the Docker machine. Yeah, you don't need to do this if you are using Linux. Yeah, but now, yes, I can do it. Okay, the first one is the command that we have running here in the container. And we can see that the user ID is not root, is 2000. If we check the same, but using root. Let's do this again. We can see that the sleep 90 command is running as root. So that's the difference, right? If we use the user parameter, we can run the container as a different user other than root, and it also maps a non-privileged user on the host machine. Again, this command that I execute, it was to get a privileged container inside the Docker machine in the Docker desktop version of macOS. You don't need to do this if you are using Linux, because if you are using Linux, you are running Docker in your host machine directly. So in these cases, I want to see something inside the Docker machine, I need to get inside the host. So basically, I'm running a privileged container, sharing the PID with the host, and it's the same that executes commands on the host machine. Good. Let's move forward. So here, I have a couple of screens that basically show the same I was talking about before. Maybe you're wondering what happens if our application needs to run as root. Maybe, I don't know, maybe you have mentioned that for any reason needs to run as root. It kind of runs as a low privileged user. What can we do in those cases? Well, that's when it comes to the user namespace remap. This is a fantastic feature that makes use of the Linux user namespace we have talked about before to remap the root user within a container to a less privileged user in the host machine. This is my favorite security feature of Docker. There is not many people that knows about this feature, and it's pretty interesting. Because for the container, it's running as root, right? And your application uses the root user, but on the host machine, it's a low privileged user. So this is actually super interesting to prevent from privilege escalation attacks and escape the sandbox and other security issues. But this feature is disabled by default. If we want to enable it, we have to edit the Docker daemons config file and add this line. Usually the daemon.json configuration file for Docker is located under etc/docker. And probably it's going to be empty. So you need to add this line, and by specifying the default parameter Docker will be used the doc remap user and group to make the remapping, right? So after doing this, if you run a container, the user within a container is going to be root. But if we do the same thing that we did before, tracking the process on the host machine, you will see that the user running the process is not root. It's a low privilege user. This belongs to the doc remap, right? Let's see. I have a video here for this feature. I will not do a live demo for this because I need to change my Docker configuration, and I cannot do it. It will alter some other practices. But I recorded a video for you. So here I just added the line to the Docker daemon, and I'm running a container that has the nmap tool. So as you probably know, if you come from security, for running the /o parameter, you need to be root. Otherwise, nmap will fail. And if we track the nmap process from the host machine, you will see that on the host machine, nmap is running as a low privilege user, right? Nmap works perfectly inside the container because for nmap, nmap is using the root user. So the requirement of nmap to run the -o parameter is compliant, so it's okay. So it runs perfectly, but in our home machine, it's running as a low privilege user. So again, I find this feature super interesting, and it's not well known. Very few people know about this feature, and it's super useful. I hope you can implement it on your environment as well. Good. So let's talk about control groups. Docker makes use of control groups or C groups for resource limitations. We are talking about CPU, memory, among other hardware resources, right? In the host machine, the C groups are located under this path. Creating a new directory here means creating a new C group of the corresponding type. You have different C groups for memory, CPU, and other hardware devices. And Docker creates its own for each one, as we can see in the picture. At the moment of running a container, Docker also creates a new C group for it within the Docker folder, right? And let's see this on the practice as well. I will exit this. Okay, this one, the other console. Let's do some, okay. This one is my shell inside the Docker machine, right? For you, if you're using Linux, it will be your shell in your host machine. So if we go to this C group, we can see here the different C groups that we have. And if we do a ls/docker, you can see that Docker creates folders for itself. We can move into one of this one, for example, memory, Docker. And for now, we only have two containers here. One is the Apache that I have run before, and this one is this container that I'm using to run commands on the Docker machine. And if we container, how to stop. So if I check it again, okay, it's still probably terminating. So if I run new container, we should see the folder here. Yeah, I see a new one. I believe this one is the folder that Docker created for our new container, for the C group of the new container. Yeah, so if I get into it, 3180. So now I'm inside the C group of this container, and if we check the contents of memory dot where is this limit in byte. This one shows the available memory for this container. By default is the whole available memory in the host machine. But we can limit this if we want to. We can run a new container, but specifying a different amount of memory. So again, I will run the same container, but I will specify memory 50 megabytes. That should be okay. So now I have a new container here. So I will move inside it folder. And if we check the memory limits in bytes file, we can see that it's no longer the whole available memory. It's now quite less. It had been adjusted to the memory that we have specified in the command, right? So Docker makes use of these C groups to limit the hardware resources for containers. This is the way that it works, right? You have, back to the presentation, you have different parameters to specify other hardware limitations. You can limit the CPU and other peripherals. I recommend you to take a look at the official documentation, because these commands, these parameters vary a little bit depending on where it is Windows or Linux, the system of the host machine. So I recommend checking the official documentation for more info. Means my idea was to provide you a look at how this works. Good. Okay, that was it for Docker containers. If you have questions, you can drop them on the chat. If you agree, I will do a 2-minute break just to go for a glass of water, and then I'll be back to start with securing Docker images and the final part, which is the Kubernetes. So I'll be back in 2 minutes, 3 minutes. Yeah, so, or 5 minutes. Okay. Okay, I'll be back in 5 minutes, so you can go for a glass of water or for a coffee, and we do the other half of the presentation. Talk to you in 5 minutes. Create a second profile or AppArmor profile is actually worthwhile. Well, yes, it takes a lot of time. And I believe that the default profile, at least for SETCOM, are actually good enough. Perhaps the AppArmor one is more interesting because it allows to lock many things. As I showed with the Nginx example, you can prevent from the attacker from writing files into different sections of the file system. So I think that the second profile is, by default, is good enough. Perhaps I will create a custom profile for AppArmor if I need to run the containers in a paranoid way. That will be good. But it's actually a good question. Sometimes you need to balance this is worth it or not, right? Okay, I'm back. Let me know in the chat if you are back, want to move forward. Okay, thank you. So let's continue now. We will talk about securing Docker images. If you are using Kubernetes, also you need to take care of your Docker images as well. As I said at the beginning, the Kubernetes will no longer support Docker, but it doesn't mean that it will not support running Docker images. Most of us actually use Docker images, so we need to learn to secure them. So one of the most important decisions when creating the Dockerfile for our application is choosing the base image, right? Some use Debian, others use Alpine, and a recent alternative is to use distroless base images. And the idea behind distroless is to use the Docker multi-stage build feature. So this feature, I find this feature very interesting, actually. With making use of the multi-stage builds, we can have like one stage for building our application and a final image with only the necessary stuff. So for example, here we have so one stage to build a configure or whatever necessary for our application, and then we copy the final binary into the final image, right? So this final image will contain only the application itself and its runtime dependencies. In this feature, we can see that if we try to get a shell inside one of these containers that are distroless, we cannot, because the shell is not present, basically. Distroless images don't contain most of the binaries expected to be found in distro-based images. And of course, this helps to reduce the attack surface. I have an example, I guess, this. My Docker folder, distroless. This Docker file, I guess it's kind of the same one of the slides. So we can do a Docker image build. Less. Okay, so this command is just to build this Docker file, and then we can run it. If we just to check that this actually works, and do a Docker container run distroless, and it works, right? The only thing that this image does is just to show this message. But then if we try to get the shell, bash. Oops. Well, it throws an error and it says that the shell doesn't exist. So as I said, most of the binaries that we can find, for example, in Debian-based images or Alpine-based images will not be present in distroless. And it's not always possible to use these images. They are actually very limited. So in some cases, it's not possible to use them, but we should consider them. If we can use it for our application, it's of course a good choice. It's very very useful for security, and it reduces a lot the attack surface. The fact that we cannot execute a shell, it doesn't mean that an attacker cannot run commands. After all, we have the Python interpreter here. So if the attacker has some skills, it's possible to execute commands, but we are making the path a little bit more difficult. That's good. Here I have another example in the slides. This is another example of multi-stage builds. In this case, it's not a distro list because the final image actually have a distro. It's based on Alpine, but still it's an interesting case of multi-stage builds, because in the first stage we are compiling the Go binary. This is a Go application. Go this is not a script. It needs to be compiled. But perhaps in our final images, we don't want to have the Go compiler and all the artifacts that are necessary to configure and compile and configure application. So we can make use of multi-stage. Every front statement in a multi-stage is a new image. So in this Docker file, we should compile, we should build the application. And with the copy command here, you can see that I can copy the output of the compilation from the previous stage. Using this from equals build, or the name that we use here, we can copy any particular binary or artifacts or folder into the final image. So in the final image, we will only have the compiled Go application and nothing else. So that's a good example of multi-stage builds. And actually, when I have to use Go applications in containerized environments, I always use this way, just to have only the binary already compiled and nothing else inside the final image is a very good practice to do it. Good. The user command. In the Docker file, the user command is the equivalent to the user parameter we have used before to specify a low privileged user. It's necessary to create the user first. That's why we can see here in this example, we first create the user and the group ID, the user ID and group ID, and then with the user command we specify that we want to use this user for running the next statement, right? Let's see this in practice. Back to the console. I guess I have here this Docker file. Good. So let's build this. No click, for example. If we check the Docker file, by default it runs a command, is whoam. So if we run the container right now, container low clip, we can see the outputs of the whoam command. But if we want, we can just get a shell inside it as well. Okay. Bash. And we can see that we are not root. If you remember from our past practices, every time we got a shell inside a container, we were root, except when we specified the user parameter. And in this case, we are not specifying a user parameter in the command line, but it's specified on the Docker file, which is the same. The user running the containers processes is this one, the one. Good. So it's good to use the user command on the Docker files directly, because you ensure that this is going to be the user that will run the processes within the container. Otherwise, it has to be specified at container runtimes manually by the user, or if you are using Kubernetes, you have to specify it on the YAML file. Normally, you will need to also change the permissions on your application inside the container. This will be the most common case. I mean, if you create a user for running the processes of your application inside the container, you need to grant the permissions to the low-priv user. So it's very common to find this run statement to change the ownership of directory. In this case, the application directory can be the directory of your application, right? Good. Let's move forward. I believe this is pretty easy. Well, this is pretty interesting. Sensitive information. Of course, we should avoid writing sensitive information on the image layers. This is pretty obvious, but well, of course, so many people still do it. But something interesting that I would like to talk about here is what happens if we write something sensitive, like a password here. Oops. But then we remove it. Is it still dangerous? Well, the answer is yes, because we can recover the password. Perhaps in this case is a pretty easy sample, because we are doing just an echo password and throwing it into a file. But perhaps in the Docker file you can see this, but there are a couple of files with sensitive information, but then they are removed. So in the container you will not see them, but you can recover it. So it's not recommended to write sensitive information on the Docker file statement. Every statement in a Docker file is a layer. I mean, the commands inside the Docker file, every command is a statement, and it represents a layer. So for each command, Docker creates a layer of that image. And finally, you will have the final image. Perhaps many files or things that happened before the last statement will no longer be present on the final image, but you still can recover them. So let's see how this is possible. And this is a bit offensive, but I need to show something offensive because I need it, basically. So let's get out here. Sensitive info. So here we have a Docker file, just an example. It's the Docker file that shows you on slides. It creates a file with something sensitive. And let's suppose that there are a couple of steps after this in a real Docker file. But then the sensitive file is removed from the container. So let's build this. This layer. And now let's see what happens if we try to do a cut of the sensitive file. Container run. And we can pass here a command to execute, and let's do a cut of the config.txt. So I am trying to get the contents of this file that I can see that is part of the Docker file. But if we execute this, the Docker container says that this file doesn't exist. And that's right, because after that, the file is what was removed. So let's see how we can recover this file. Well, we can do a Docker image save first. The path layer, which is our image. Let's dump it into a tar. Good. And then I will create a directory here. And let's decompress the image. Good. So after making the decompress of the file, we see here a couple of interesting files. Some of them are JSONs, and these JSON have information about the building process of the Docker image. And then these three are folders. And we will have one folder for each statement on the Docker file, because as I said, each statement is a layer. And this inside, now I will show you, but inside these folders, you have like the file system of the layer of the Docker image, right? The current state of the file system at the moment that the Docker file executes such a statement. But let's first get the information about the sensitive password file. There are several ways we can choose to get JSON, but let's try to correct this. I believe this can work. Yeah. Because the JSON file is actually pretty long, but if we filter this a little bit, we can get the statement of the Docker image. So in this case here, we can see that at some moment we have this. But let's suppose in a more real scenario that we cannot see the content because there is no echo. It's just copying, for example, the path config from a local config file. So in this command, we cannot see the content. We just can see that there is a path config, but then it's removed. So we want to know the content, but we cannot see it from the Docker file or from this history command. So we can decompress the layers. I will move here. The browser is easier. So we have three folders that represent the layers of the Docker image. And as we decompress this layer tar that we have here, we can see the file system of the image at that point. So in this case, we cannot find the file that we are interested in because it was not created yet. This is the first layer. So it contains the base file system, but nothing else. So we want to find the path config file that we see here. We need to check the next layer. And this will show the files that were added to the base file system. So the layer that we decompose right now is on top of the previous one. So the only difference with the previous one, with the file system, is that now we have a new file, which is a path config. And now here we can see the content. So this is useful in case that we cannot see the context on the Docker file. We can decompose the layers and look for the file inside the file system. Good. Okay, yes, that was a little bit offensive, but I like it. I hope you enjoyed it. The point is that we need to avoid writing sensitive files with sensitive information on the Docker files, even if we remove them after some steps. Good. One more thing about Docker images. There's a feature now, Docker Content Trust, that allows us to use digital signatures for images. So developers can sign their images and users can verify the integrity. On the publisher side or developer side, the developer just has to export this environment variable on their machine. And once done, if it's the first time, the developer will need to create a key for Docker, just using the Docker trust key generate and the username of the developer. With this command, we can generate a key for us. And after that, we can add ourselves or add the developer as a trust signer for a specific repository. And after these three basic steps, we can push an image signed by ourselves into the Docker Hub repository, for example. This works very well for Docker Hub, but in case you are using a private repository, it's different. For example, if you're using Docker Enterprise, you have the Docker Trusted Registry, and in that case, you have to add your certificates, and it's a little bit different. But if you are using just a normal developer Docker Hub and want to sign your images just to ensure that, well, your users can ensure that such image was developed by you, this is a good practice. And also it's very good for to use signed images. It's very, very useful for preventing from Docker poisoning images. Some days ago, I wrote an article explaining how you can poison Docker images if the Docker registry API is exposed to the internet. But if you use signed images, you can prevent from running containers from malicious images. So this is on the developer side. But on the client side, you can continue using Docker images as normal. I mean, yeah, for you as a user, it doesn't matter if the Docker image is signed or not. You can just pull it as normal. But if you can only use signed images, you need to support this environment variable. If you support this on your terminal, you can pull only images that were signed by their own developers. Here in the screenshot, we can see that first I tried to pull an image from my repository that is not signed. So basically, Docker throws an error and says that the remote trust data doesn't exist. So I cannot pull images that are not signed. But then I tried to pull the demo image that is actually signed. It was signed on the previous step, and I can pull it as normal. So, as I said, this is very useful for production environments. In this case, I'm just playing with it with my local installation, but in a production environment, it's also very good to enforce the Docker Content Trust and use only signed images. Because as I said, it's possible to, an attacker can basically poison images. Perhaps the developer is not even aware that happened, and is not his fault, but it happened, and the victims are the users. So it's good to enforce this policy. Good. Well, that was all for Docker images. Let's jump into Kubernetes. I'm pretty sure that you're looking forward to this section because today it is Kubernetes everywhere. I lost the meme where they used to use a meme from the Toy Story movie with Woody and Woz saying Kubernetes everywhere. And yes, actually I'm working a lot with Kubernetes. I actually love it. It's fantastic. I find Kubernetes a fantastic product, but yes, it's everywhere today. And it's actually pretty complex at the beginning, at least for me. I started learning about Docker years ago. And also I was working with Swarm, the official Docker orchestrator. And when I jumped into Kubernetes, I said, whoa, this is quite complex. And Kubernetes and orchestrators are used on production environments. This means you can play with Docker on your local machine, and that's fine. But then, if you are working for a company as a DevOps and need to deploy it to a production environment, you will use, or you should use, Swarm, which is the official Docker orchestrator, or Kubernetes, as it is most popular. And sometimes in my trainings, people used to ask me, what orchestrator shall they use? And I would say that if your production environment is tiny, is simple, and it doesn't require very complex settings, you can use Swarm. Swarm is the official Docker orchestrator and is pretty easy to use and allow to scale services. It's pretty useful, but when it's not enough, when you need to specify more specific requirements for your installation, that's the moment to jump to Kubernetes. So let's talk about security in Kubernetes, but before jumping into security itself, let me do a quick review on the Kubernetes architecture, because I'm suspected perhaps there are people here that never used Kubernetes before. So I will do a quick review on basics of Kubernetes. This is the architecture of a Kubernetes cluster. Master nodes here host the control plane. These components inside the control planes are also containers. And you have, first of all, the XCD. The XCD is where all the cluster information is stored. It's a kind of database, and it's a pretty important component. And then we have the KubeAPI server. The KubeAPI server is the main Kubernetes component. It's the heart of Kubernetes. All the requests pass through the KubeAPI server. And then we have other components like the kubescheduler, for example, which function is pretty obvious. It's just the component that is scheduled the pods to be running on the cluster, etc. And then the key controller is another important component that controls several things of the cluster. And maybe we can have a cloud controller as well. It depends on if we are using a cloud provider or not. Perhaps we are using Kubernetes in an on-prem installation and we don't have this. But basically, these ones are the components of the Kubernetes control plane. And then we have the worker nodes. The worker nodes host the applications, the workflows, the bots, deployments, or whatever we have running on our cluster. And by default, master nodes in Kubernetes don't run containers of applications, only run the containers of the control plane. We can modify this setup. We can, if we want, we can run containers inside the master nodes as well, but by default, and it's obviously recommended not to run container of our application on master nodes and use the worker node instead. So in the worker node, we have our containers, and also we have, of course, the container runtime. And this can be Docker, but you know that we already talked about this. Docker will be not longer supported. And this will be, for example, containerd. And then we have the kube proxy to handle network connection, but normally it's used CNI for network communication between pods. That's why the kube proxy is another component. And the kubelet is probably the most important component inside worker nodes. And I have to say that the kubelet is also present in master nodes, but it makes more sense here in worker nodes because it's the Kubernetes agent. So the kubeAPI server master node talk to the kubelet in each node to perform whatever necessary action, basically. Is the Kubernetization, and it's the most important component on worker nodes. Good. So as I said, the kubeAPI server is the main component of the control plane. All the actions that occur within a Kubernetes cluster go through the kubeAPI server. This component exposes an API REST that the other components consume as clients. So the kube scheduler, the kube controller, kube proxy talk to the kubeAPI server as client, and the kubelet talk to the kubeAPI server as client as well. But the etcd and the kubelet are also servers. So the kubeAPI server talk to the kubelet and the etcd as client as well. So the communication between all these components can be secure using TLNet certificates. By default, the cloud provider, for example, creates the certificate for you. So by default, this is secure. The communication between the Kubernetes components is secure by default. The cloud providers will create the certificate for you. And if you're using an on-prem installation, but you used a kubeADM tool, the kubeADM tool is the most popular tool to install Kubernetes in an on-prem cluster. kubeADM will create the certificate for you as well and set it up. And if you want, you can create the certificates on your own, or if you are installing Kubernetes the hard way, you have to create the certificate on your own. It's a good practice. I mean, it's very tedious. It's very tedious. I wrote a step-by-step on a white paper explaining how to create the certificate for each component and how to configure it. And it's very tedious, but you can do it. And it's a way to choose the certificate that you would use, to choose the certificate authority and use perhaps the certificate of your company. If you want to do it, you have to create the different certificate for each component. Basically, first of all, we have to create a CA for our cluster, at least one, at least the Kubernetes CA, but it's also recommended to create also a CA specifically for the etcd, because if the cluster is pretty big, perhaps you will have a cluster of etcds only to high availability. So it's common, it's a common practice. So you will have at least one CA, maybe two. And on one hand, we have the server certificates for the server components. We already saw this, the etcd, kubeAPI server, and kubelet needs server certificates. And on the other hand, we have the client certificates. Kube scheduler, kube controller, and kube proxy to talk as a client. And then we have the kubelet client certificate to talk to the kubeAPI server as a client. And the kubeAPI server has the server certificate, but also two certificates as clients as well. One to talk to the etcd and one to talk to the kubelet. Let's see, I will not explain how to create the certificate for each one. If you need to know this, you can check my white paper. I will share it later. But let me show you at least how to configure the certificate for the kubeAPI server, which is the complex case, the most complex case, as it has 3 different certificates. So to create them, you can just use OpenSSL and that's it. But then you have to configure them. And for each Kubernetes component, you will find a config file, basically. This is the config file for the kubeAPI server. So when the kubeAPI server starts, to read this config file and take care of these parameters. So in blue, here, we can see the path to the CI, the certificate. CI certificate is the CI certificate of our cluster. Then in red, we have the certificate to talk as a client to the etcd. And also, we can specify here the CI certificate of the etcd cluster. It's not the same one that than the other CI. So we have two, basically, one for the etcd and one for the default Kubernetes components. And in red, we have the certificates to talk as a client to the kubelet as well. And finally, in yellow, we have the certificates, the server certificate for the QAPI server, right? So this is the most complex component to set up the certificates. We have to specify many. Then the config file for etcd and kubelet are pretty similar to this one. For the other components, for the kubescheduler proxy, the configuration is a little bit different. It's easier. But again, if you need or you want to create custom certificates for your cluster, feel free to check my white paper, and there I wrote this step by step. Good. So when it comes to authentication, Kubernetes supports several methods: basic with user and password or tokens, TLS certificates, and protocols like LDAP, Kerberos, or similar systems. A good practice is, of course, to avoid using basic and implementing TLS certificates instead. Though, depending on the size of our organization, it may be more convenient to use LDAP, Kerberos, or similar systems. But if we want to use TLS certificates, we can use it just, it's pretty simple. We just need to execute 3 commands. The first one is to create, a key for our user. For example, an admin user that wants to remotely connect to a Kubernetes cluster. So with this command, we generate a key for the administrator. Then we need to generate the certificate signer request. And here is something very important, which is to specify in the organization of the subject the group for this user. It can be empty, but most likely we will need to specify a group. This one, system master, is the administration groups by default in Kubernetes. It's a group that already exists and have all the privileged. So if we are creating the certificates to perform a remote connection of a user that is an admin, we need to specify the system master group here. So with this command, we will create the certificate signing request, and then this signing request needs to be signed by the cluster CA. So with this command in the cluster, we will take as input the certificate signing request, and we have to specify the CI certificate, the CI key, and the output of this command will be the admin certificate. If you have used kubeadm to install your cluster, these files, the ci.cert and ci.key, are usually under /etc/kubernetes/pke. And under that folder, you will find these 2 files to sign the the certificates of your users. Good. So after that, the user can create this config file. This is by default located under this path on the user machine. And here we have to specify the different clusters and certificates that we have to connect to remote clusters. So on one hand, we have the cluster information. We need to specify the certificate authority, the certificate authority. And in the server field, we need to specify, of course, the IP address and ports where the QAPI server is listening for connection. And on the other hand, we had to specify the path to the certificate of the user, the admin certificate that we just created and the admin key. And the clusters, the context field is just to show this information. In the context, you specify basically what user access what cluster, right? So in this case, we have a context where the admin user accesses the case cluster. This exists because you can specify many clusters, many users inside the same config file. So in this case, I have only one, but you can have 10 clusters, 10 users with different certificates, and you need to define the context to specify what users will access what cluster. And then from the command line, you can choose a current context, and Kubernetes will automatically perform the connection to such cluster using the specified certificates. Okay. Regarding authorization, again, Kubernetes supports different methods: node, ABAC, RBAC, webhook. But for users, groups, and service accounts, we should use RBAC. There are 4 Kubernetes objects for this mechanism: role binding, cluster role, and cluster role binding. Role and cluster role are used to define the set of permissions. The difference is that role is namespace while it works for resources within a Kubernetes namespace and specific Kubernetes namespace, while cluster role is cluster-wide. It works across all the namespaces, right? So once we have a role or a cluster role defined, it can be bind to users, groups, or service accounts using the binding objects. So on one hand, we have users, groups, or service accounts. If you don't know what service accounts are used for talking to the QAPS server from within a pod. It's super interesting also from a security perspective, because usually when an attacker compromises a container that is running within a Kubernetes orchestrated environment, one of the first steps is to check the service account that is binding inside the container. By default, there is always one, but the default account doesn't have privileges by default, but you should check it because maybe the administrator binds some privileges to the default account. That will be very bad from a security point of view. Or maybe the pod has another specific service account that has some privileges that we can abuse them. So let's create a role binding just to understand how this works. But back to this row, basically we have users, groups, or service accounts, and then we have the permissions. Roles defines permissions. It means the actions that the users can perform. For example, get pods, get secrets, or whatever. And then we have the resources. This means what objects those actions can be executed. Yeah, it can be pod services, secrets, volumes, and more. So let's see this on the practice. I have here an example, but let's see its real demo. Okay. We move to my Kubernetes folder. I will quickly show you how service accounts looks like inside a pod. For example, if we do let me check what cluster I'm using. Okay. kubectl run, I don't know, US nginx1, just to run nginx container. Now, if we get a shell inside it, we can move to run secrets, Kubernetes Here we will always find this by default. The administrator can specify not to by mode the service account inside pods, but by default it's going to be here. And if you move inside this folder and you do a cat token, you will get the JSON web token of this service account. So we can copy this, and if we want, we can decode it here in the JSON web token page. So we paste it here, and you can see that this is the Kubernetes service account. It's the default one. It's in the default namespace, default name, default. So this will not have any interesting permission unless the administrator binds a privileged action to it. Normally it will not be this way. What will happen is that we will have another service account here with a different token, and the permissions are bind to that token. So it's interesting to check it from a offensive security point of view, because if this token has permissions to create pods or to list secrets, for example, as attackers, we can abuse it to compromise the whole cluster. Most of the attacks inside Kubernetes containers are abusing these service accounts tokens. Good, so we move forward. And here in the RBAC folder, I guess we have a couple of files, or maybe I have it open here. Yes, okay. Let's create our role and our role binding, just to understand how this works and do some checks regarding permissions. This is a basic role definition file in Kubernetes. Basically, we are creating this role for the backend namespace. We are assigning a name to it. And here is the important part. Basically, we are specifying the resources. As I said, resources are pods, secrets, volumes, or whatever object inside Kubernetes. And the verbs are the actions. So these can be get, list, delete, create, and watch, or many others, right? So the first thing we have to do is to create the role. So I will do it. I will leave this spot with our folder. Okay. So let's do one kubectl create up and create this role. Okay. And before creating the role binding is the option that will bind this role to the user group or service account. I will do it with a service account. So I have to create the service account. And here in the role binding pod file, I can see in the subject what is the service account that I have to create. Well, you can change this and just create this and create the service account. It doesn't matter. But the role binding object has three important parts. First one is the metadata. The important part here is where this role binding is going to be created. It has to match the role namespace as well. Then the subject is an array, so it can be many users, many groups or service accounts to which the role is going to be bind. And in the role ref, you have to specify what role, basically. So in our case, we are going to bind the pod reader role. This name has to match to the role name. I mean this one, pod reader role, same name here, pod reader role. So this is the option that binds this role to the subject, to the service account. So first I will create the service account. And it's important to specify the namespace. And now I can create also the role binding. Okay. if we want, we can do a kubectl get role, for example. We will see we have the pod with the role created, and we can get the role binding. And we have our role binding created here. And if we want to see some more details, we can do always a kubectl describe role binding name and space. And here we can see the role wrap and also the subject. In this case, we have only one service account binding to the role specified here. Good. So what we can do right now is to check if this is actually working. There is a very nice feature that Kubernetes has by default, which is the kubectl out command. And with this command, you can check the permissions that you have or you don't have as a different user or a different service account. So, for example, I will check if can I get pods as system service account. You have now to specify the namespace, backend in my case, and the name of this service account, suppose token. So if our role and role binding are working fine, we should hit yes here. Fuck. I had to specify the namespace as well. I always forget to specify this, and it's also a problem. So now if we specify the right namespace, we should get a yes here, because this service account can get pods inside this namespace. If you don't specify a namespace, it will check it on the default namespace. And in this case, this service account doesn't actually have permissions to get pods in the other namespace. But if we change the verb, I will check if I can, for example, the secret. Now it's going to say, no, you cannot. Because I cannot. If I check the role, I can only get on these pods and nothing else. I should have secret here, and the possibility to be secrets is if I want service account to also be secrets or create secrets or whatever. So this means that our role and role binding are working fine. So now we could bind this service account into a pod, and that pod will have the privileges to this and get pods in the backend namespace. Okay, in a black box and in a gray box analysis, it's super important to check these permissions, because as I said, most of the attacks abuse the service accounts token. So one of the first things that you have to do if you are in a black box analysis is to check the service accounts by model in the pod that you have compromised. And if you are doing a gray box analysis and you have a console like this one I have right now to execute some kubectl command on the cluster, you have to check the permissions of the service accounts that are created inside such cluster. Of course, this out_can_I command is useful, but if you need to check many, it's not so comfortable. So I would like to show you 3 plugins that are very interesting for perform RBAC audits. I have them already installed, but if you don't have them, the first thing you have to install is Cube. I will share some chats. Install Cube is very easy. This is a plugin manager for Kubernetes. So the only thing you have to do is just run this command on your console and then export the environment variable. And that's it. After that, you will have Cube installed. With that, you can install different plugins. One of the plugins that I would like to show you is Hookm. So if you don't have it installed, you have to run kubectl install who-can, for example. Of course, run this command after you have installed Q. Otherwise, of course, it's not going to work. And when you have installed who-can, the plugin, you can use it. I will not install it because I already have it installed. So when you have installed, you can run, for example, kubectl who-can. And basically, you ask who can do something. For example, who can list secrets. And the output of this command will show you who can list secrets. What's my question? So you can see here the cluster role binding, the subject. The subject is basically who. What type is it? Is it a user or is it a service account or a group? And the namespace, right? So as we give who can get pods, we should see our. I did not specify the. I didn't specify the namespace. Probably it's not here, but we should see the one that we had created. This way. Okay, it doesn't. Yeah, here. So here I asked who can get pods, and here we can see the service accounts that we just created before. So this is the role binder we created, the namespace and the name of the service account. So this is useful to check for overprivileged service account, but it's not the only plugin. I would like to show you two more, and I recommend you to use the three ones because perhaps they show a different result. So the next one is access matrix. kubectl access matrix. You need to install it to run kubectl kube access matrix. Install access matrix. I have it already installed. So with this, you can specify, for example, a service account. Let's use from the kube system namespace kube proxy should exist. See. Well, this tool shows the output in a different way, right? It's just here you can see the name of the potential permission, and I mean the resource. There's the Kubernetes resource, and then you have here the permission, the list of permission. If this service account can list, create, update, or delete resources within this API endpoint. So, for example, for the kube proxy, we can see that it can list services. Services in Kubernetes are the services are the one that you create when you need to expose a pod or deployment for remote access. For example, if you create a deployment of a web server, you will have a service probably on port 80 for remote access. So as a kube proxy handles networking, it has the permission to list services. Good. And the other tool that is my favorite is kubectl view. I recommend you to use this tool. I find it's the most complete one. This opens a web page here. It takes a few seconds to get the information. Okay, perhaps the user interface is not beautiful, but it's very, very useful to check the permissions. Here you will see all the cluster roles and if they actually have permissions over the different Kubernetes API resources. For example, in roles, we should see this one is secrets. There are. This is a different cluster. Yeah, we can see. Okay, in most Kubernetes installations, you will find this system controller bootstrap signaler under the kube system namespace that had permissions to get these and watch secrets. So if you are performing an audit, it's actually very useful to check if you can compromise a pod that has these service accounts by Monday or so, because you have the permissions to list the secrets and get, I don't know, probably credentials or other interesting sensitive information. Good. So this one is my favorite tools to check the airbag permissions. So please, if you are performing a Kubernetes cluster analysis, use this tool to get the information on this. Make sure that there is no overprivileged service account that might be compromised by an attacker. Okay, back to the presentation. This is the example that we just saw. These are the tools. And let's jump into Kubernetes secrets. That's a very interesting topic to talk about. Because if you have been using Kubernetes, probably you came across that Kubernetes doesn't encrypt secrets. It uses base 64 codification, which is not encryption. And I find this truly interesting. And also, it's a little bit curious. Why Kubernetes handles secrets this way is I don't know. I don't know really. Because, for example, Swan, which is the official Docker orchestrator, actually uses encryption for secrets, but Kubernetes doesn't. When you create a secret in Kubernetes, you have to encode it in base 64, and that's not encryption. It's codification, so you can get the plain text of this with any base 64 decoder. And so let's just take a look at this. I guess I have here secrets. Maybe I have it open here. Okay, this guy. Okay. This is a classic Kubernetes file to create secrets. As I said, this is base 64 codification. It's not encryption. If we create this, for example, qt create simple secret. You can get the secrets now. And if we describe it, nice secrets. We can see the keys, but we cannot see the values. Means that Kubernetes doesn't show the sensitive information, but it's still here in the YAML file and is codified. So it's not secure. By default, it's not secure. And the way that Kubernetes handles secrets is not secure. So most companies are opting to use third-party solution for handle secrets, which is good because, as I said, default way for Kubernetes to handle secrets is not good. So most companies are using open source solution. For example, HashiCorp Vault or CyberArk Conjure are two of the most popular solutions that have an open source version that you can use. They allow us to handle secrets in encryption, in encrypted way, and with many other features that are actually very useful for using secrets in Kubernetes. Also, it's always a good practice if you can to encrypt the HITB database. As we were talking about before, the HITB is like the database of Kubernetes, but Alred is not encrypted. So secrets are stored in this database. And this means that if an attacker compromises the HITB cluster, he can just dump all the information in the XCD and get the secrets as well. So here it is a link to the official Kubernetes documentation where they explain how to encrypt the XCD. So regardless, anything is good to encrypt the XCD if you can do it in your cluster. And on the other hand, of course, we can use also if we are using a cloud provider, we can use the secret managers of the cloud providers. Each cloud provider has its own. AWS, GCP, Azure. We can use these managers to create secrets, and then there are different ways to use those secrets inside the pods that need to consume the secrets. So it depends on us. I recommend to use a solution, a third-party solution. Of course, I recommend to encrypt the HITB, but on top of that, also use a third-party solution to manage Kubernetes secrets if we are using Kubernetes in a production environment, right? Okay, we are almost reaching the end. I will like to talk about a little bit about security context, which is actually very interesting. When we talk about Docker, we saw many security features that can be applied at container runtime. For example, the addition or removal of kernel capabilities. Just checking a question. If I remember well, by encrypting the XCD, you are encrypting everything, right? So the secrets and all the rest. If I'm right, the tutorial that Kubernetes provides is just to encrypt the whole database, if I'm right. Okay, so we have talked about before about capabilities, for example, kernel capabilities that you can add or remove. You can do it in Kubernetes as well. All the features that we talked about before at the securing container section, you can apply them in Kubernetes. When we were talking about AppArmor, SecCon, all those capabilities, all those features can be applied on Kubernetes. You have to use the security context for doing that. Here we have an example. A security context, you have to know that the security context can be defined at pod level or a container level. In Kubernetes, you have not used it before. The pods contains the containers. So a pod can contain several containers inside it. And there are some features that you can apply to all of them. This means that it's a definition at pod level. For example, this one, the security context runs user, runs group. You specify a user ID and user ID, a group ID to run all the containers inside this pod. But then we have another security context that can be applied only at container level. For example, this one, allow privilege escalation, false. It's a very interesting feature because basically it prevents processes within the container from gaining more privileges than its parent process. So it allows to prevent some eventual privilege escalation techniques to escape the container. No, if I remember well, the allow privilege escalation is set to false by default. But just in case, it's good to to apply it. Just in case, I should check. I'm pretty sure that by default this is false, but we should check. It's always good to just put it here, just in case. Good. So let's see. I would like to show you an example here in practice. Okay. this can be used as well to for bad. I mean, for example, if we check this file in a privilege pod, for example, you can define a security context privilege true, and this privilege true is the equivalent to the privilege flag in Docker. I hope you remember when we were talking about permissions in container runtime. If you remember, I ran a container with the privilege flag, and this was very bad because all the kernel capabilities were allowed for that container. Well, this privilege statement is the privilege flag. So, you don't have to use this. I mean, if you use it, you know that you are giving lots of permission to your container, and it's very easy to escape the container and get access to the host machine. But we can use it for good, and here we have just an example. Just to this is very simple example, just to specify a user ID, a group ID. So we can do a test, simple test for it. And so just run and keeps it directly. This will create the pod. And if we get a shell inside it, yep. Let's see. Okay. Okay, I have a problem with this command line today. Okay, so we can see that the container running inside this pod is actually running as a user ID 1000. It's the one that we have specified here in the security context. If you have to know more about this, I have here, this one is the API reference, and you can see the different options that you have. This is the low privilege escalation. Perhaps here we have the answer to the questions. Always true, always. Okay, here we have the answer to a question that came in the chat. It says that low privilege escalation is true always when the container is run as privileged. That is the flag that we were talking about before, or it has this cap sysadmin. So I believe this means that by default this is false. But okay, and I will share this link in the chat. There are of course, other parameters that we can specify in the security context are interesting. The capability one is super easy to use, and it's the one that allows us to drop or add kernel capabilities, just as we did before with Docker container. Should receive a question. What is the name of the tool that you run in the local host? I guess you're talking about Airbag View. Yes, Airbag View, the one that I ran before. You can install it using Q. Just kubectl to install Airbag View. Should work. Airbag. Yeah. Okay. Okay, I was about to share also this link. If you want to know more about kernels and features that you can enable, disable using the security context. And also, it's very interesting to take a look at the security policies, because if you have 1,000 pods, perhaps it's a little bit complicated to make sure that all the pods are actually running with the right security measures, to say it some way. So with the security policies in Kubernetes, you can restrict the things and say, okay, if I would only run pods that, I don't know, are running as a low privileged user. So you can specify it in a pod security policy. So is a developer try to run a pod using the root user, like by default, Kubernetes will not schedule that pod because it will not match the security policy. I find it very, very useful. Here in the documentation, I will share this as well. We have some examples. Some of them are like not very restricted. This one is super restricted. I believe that using this one, nothing will work. But it's a good example. You can see here, you can specify set compare file, up armor profiles, set it to false, set the allow privilege escalation to false as well. Drop all the kernel capabilities. I believe this is going to break everything. So take care, don't run these policies in your the cluster of your company. But probably you will break everything. But it's good to test and try. In your cluster to test things, you can create these security policies and check. I find it super useful when we have a very big cluster and we cannot control or we cannot verify. Perhaps the security team of a big company cannot verify one by one all the pods definition file. So in that case, they just create a policy and all the pods will have to match the policy to run. So I find it also very interesting. Okay, so last topic. We are almost ready, almost at the end. Thank you for being with me in this very long workshop. The last topic is about network policies in Kubernetes. This is actually super important because by default, all the traffic is allowed within a Kubernetes cluster. We might want to change this. All the pods inside a Kubernetes cluster can talk to each other without any restriction. It doesn't matter if they are in different namespaces. If you have one in front end and one in back end, they can talk to each other. There is no restriction by default. So it's very important to learn about network policies to create better policies to, for example, by default, deny all and then create policies to allow a specific traffic, right? This is an example of a network policy to deny all. If we create this, it's like a partner network, isn't it? Yes, exactly. Yes, it's like that. I will do a demo right now, but yes, by default, each pod can communicate with each other. So it's very good. Is by default, we create this policy. This will deny everything. But of course, we will lock all the connections. If we deploy this network policy in our cluster, no one will be able to communicate with each other. So after that, we need to specify, to create the rules that are necessary for our cluster. This pod selector empty means that it will select all the pods. Because in a different network policy, you will have to specify normally a selector. Well, in this case, it doesn't apply anyway. But I will show you a demo right now where I use a pod selector. This means that I apply a policy to a group of pods. And with that, I can either deny or allow traffic, right? Here we can see another example. In this case, this network policy allows pods in the same namespace to communicate with each other, but pods in a different namespace will be able to reach these pods. In this case, we are talking about packet namespace. So with this policy, all the pods within the packet namespace will be able to talk to each other. But if we have pods in different namespaces like frontend, we'll not be able to send packets and talk to them. So perhaps it's useful to isolate different namespaces. In real life, it's common to have namespaces for example, web environment, production environment. So in order to block connections between that environment and production environment, you need to create something like this. Apply a network policy to block all the traffic, isolate the traffic as the different namespaces, right? Network policies can be as complex as we want. It's possible to fit the right ports, protocol, network ranges, a specific route of ports, namespaces, whatever. Actually, it can be really complex. I will show you a demo, the last one for today. Okay, I will do the demo in a GCP Kubernetes cluster because it's easier. For the demo, I need to open one more file here. I will create two pods. One is like in an internal network and the other one is in an external network, right? These are just labeled. I create these pods and they can talk to each other by default. Yes, we will create one pod, this is an Elasticsearch with this label, network internal, and then we will create an external pod, a web application, and it has the network external label. So first of all, we will create these ones. So here I have my console that lost connection. Let's connect it again. This is just a Kubernetes cluster in GCP. I used to use GCP as cloud provider for Kubernetes. Okay. Let me check that I'm in the right cluster. Yes. Good. So here I have Motion folder. I have my YAML files. So the pod internal is just the YAML file I showed you before. Let's create this one. Pod internal. And now I have a pod external file, which is the web application. So I will create this one as well. External. Right. So I have created this pod, GCTL get pods. We can use the while to see the IP addresses that they have, the internal IP addresses they have. And both of them are running. Okay, so now I still did not apply any network policy. So if I get a challenge at one of them, for example, the web app, and try to ping the Elasticsearch, it should work. I mean, I should be able to reach it. So the ping is working. So from the web app pod, I can reach the Elasticsearch pod. It doesn't matter that they are in different, they have different network labels because I still didn't apply any network policy. I will do it right now. So I have here, where is this line? Okay. This network policy is just the most simple one. It's just to deny everything. So it will deny everything, but it had a pod selector. So it will isolate only the pods that have this label. So you can see here that I'm specifying a pod selector and I have the key match labels. So I'm asking the network policy to match the following labels. So all the pods that had this network internal label will, this policy will be applied to them. So if we check the pods that we have created, the Elasticsearch has this label. The other one doesn't have. The other one have the network external. So This network policy will isolate the Elasticsearch if it doesn't work well. So let's create this network policy. So now the IP addresses are the same, and we can get again a shell inside the web app. And let's do the ping again. So remember that this IP address is from the Elasticsearch, but now it doesn't work. So it means that our network policy is actually working, and we have isolated the Elasticsearch pod in the internal network, right? Okay, as I said, network policies can be as complex as we want. If you want to take a look at the documentation, you will find here in the official Kubernetes page many examples. As I said, you can filter by protocol, specific ports, specific ranges. I don't know, but it's possible to create very, very complex network policies for our cluster. My recommendation is always create a first policy to deny everything, and then create the other ones to allow a specific track, right? Good. So that was all. But before finishing, I would like to give you a gift. Perhaps you know, but in February we will run a 2 days training on Docker and Kubernetes, and you want to become expert on it. This training has much more stuff, also from the offensive side. And I would like to give you a discount code. So thank you for being with me in this workshop. And yes, I will share the link here. This is the workshop. That's the workshop, and the discount code is Docker VIP. If you use that discount code when making the registration, you will have a 10% of discount. That's a 2 days training. It's very intensive. We start from scratch. We talk about Kubernetes itself, networks, many different features of these technologies, and then we jump into offensive side, black box analysis, gray box analysis, white box analysis. Is much more that you have seen here. So if you are truly interested in these topics, I recommend you. Anyway, if you need to add something, you need something more specific for your company or whatever, feel free to reach me out on my email or by Twitter or any. So thank you so much to you. Thank you for being with me and be here until the end. I was very happy to share this with you. It was super, super funny. I don't know if someone from HITB want to say something. Yes, I can share the slides. I will then talk to the HITB people to find the best way to share the slides. You're welcome. Thank you. Thanks to you. Please feel free to reach me out. Yeah, I don't know if there is a Discord channel, but if there is one, I can share. Yeah. Fantastic. Yeah, I can join and share also the slides. I'm happy that you like it. If any questions, take note of my email, just email me. I'll see you in the next time.